Since many years ago, Ubiquiti has been releasing one after another one L3 switches, claiming to have layer 3 capabilities. But only starting from about 2 years ago, Ubiquiti started supporting the router setting utilizing those layer 3 switches. However, there's one crucial missing feature since then. You may know for inter-VLAN routing to work completely within a layer 3 switch, you need ACL support. Finally, recently, Ubiquiti started supporting the ACL setting in network controller, and this feature has been waited by many people for a long time. In this video, we will discuss how ACL works from backend perspective, what if you only have one layer 3 switch, how it works, and what if you have two. In the end, we will summarize what are the limitations or things I hope Ubiquiti can improve in the future releases. This video is for people who use UniFi routers. If you use third-party router, for example pfSense, I will have a follow-up video specifically for pfSense and UniFi layer 3 switches. In my lab environment, I use UX3 Pro as the router. Then I have two layer 3 switches. I maintain two VLANs using the router, then two VLANs by the first layer 3 switch, and the other two VLANs by the second layer 3 switch. Let's first talk about one layer 3 switch scenario. In the right side, you can see the network setting in UniFi Network Controller. I have VLAN 10 and 20. For example, 10, you can see it's managed by UX3 Pro as the router. Then I have VLAN 66 and 88. For example, 66, you can see the router is the USW Pro 24 switch. By default, if I do not do any firewall rules or ACL changes, the access will look like this. So for the four example VLANs, they can access each other without any problem, right? That's the default result. But in real world, one of the main reasons you want to introduce VLAN is to achieve more granular access controls. So that's why in this video, I want to achieve this type of access control. From the VLAN 20, which is maintained by the router, I do not wanted to access the VLAN 10 and VLAN 66 and VLAN 88. From the switch perspective, I do not want the two VLANs access each other. For the other router managed VLAN, the VLAN 10, I do wanted to access the two VLANs which are managed by the switch. Let's see how we can achieve it. I have 4 Linux virtual machines. They connect to the VLANs shown in the terminals. Before we make any ACL change, let's validate the current access. For example, from VLAN 10, let me ping VLAN 20. Yeah, no problem. From VLAN 20, ping VLAN 66, pingable. From 66, ping 88. Of course, no problem. From 88, ping VLAN 10. As expected, they are all accessible. Normally, when we want to restrict the access among VLANs, we use firewall rules, right? So for example, if I go to security, firewall rules, if I create an entry, so let's say from 20 to 88, if we say drop, source type network, source network 20, and destination network 88, yes, we are able to do that. That makes sense. And later in the video, we will talk a little bit about what's the difference between this type of firewall rules and ACL. But when it comes to the VLANs, which are managed by layer 3 switch, you shouldn't be able to create firewall rules at all because this type of inter-VLAN traffic is completely within this layer 3 switch. It won't be routed to the router at all, right? If you create the firewall rule between 66 and 88, it's useless. However, it seems to be a bug. See in the source, you are allowed to choose 66. So now all of a sudden, I'm able to create a firewall rule between 66 and 88. So let's try to add it. Drop 66 to 88. add rule. Let's validate whether it's effective at all, right? In the VLAN 66 Linux, let me run the exact same ping command, ping 88. Yeah, it is still pingable. So even though the firewall rule seems to be activated, it's not taking effect at all. I think it's a bug. If you think differently, please let me know in comments. Having talked about the firewall rule thing, let's go to the ACL. Let me delete the useless firewall rule first. Go to network. You see this option, L3 network isolation. If you enable it, you can create entries. So let's create the first one, 10 to 20. This type of limitation can be achieved using regular firewall rules, but we can also do it using ACL. Let's do it, VLAN 10 and VLAN 20. First one done, then the second one from 20 to 66. Here you can choose multiple destinations, so we can also add 88. Let me choose 88 as well. Create. The second one is done. Create the last one from 66 to 88. So this is the one which is absolutely needed using ACL because it's inner two VLANs within the L3 switch. Great. So now you see 3 lines, but internally it's 4 different rules. Make changes. We are done. Before going to the backend to check the configuration, we can simply validate the access, right? So let me run the exact same ping commands in the 4 terminals. VLAN 10 first. Okay, it cannot ping 20 anymore. VLAN 20. No, cannot access 66. From VLAN 66. Cannot access 88 from 88. Yeah, it can still ping VLAN 10. So for all the rules, they are already effective. They are working as expected. The ACL setting is very simple from the UI side. So then let's dig deeper, go to the backend. Let me SSH into the layer 3 switch. Go to the temp folder. There should be some configuration files. Display the system config. Let me search ACL. Okay, see the section about ACL rules. There are totally 4 as we expected, and let's examine them a little bit. For example, the first one, the name, VLAN 10 and VLAN 20, the first rule we defined, and the source, destination is 20. Very simple. The only thing is about the name. You can see it's using and instead of to, which means there's no direction. It covers both directions. Then let's go to the CLI to check some more detailed settings. Telnet to itself. Enable config. Let me run the command show IP access list. So it lists only one access list with this hard-coded name, global IP ACL, and interestingly, it has 9 rules instead of 4. If we want to check the details for this particular ACL, show IP access list followed by the ACL name, global IP ACL. Now we can see more details. It covers all the interfaces. The first one, action is denied. Of course, we want to limit the access, right? We want to isolate the network. Protocol IP, source IP address, VLAN 10, destination, VLAN 20. The wildcard mask basically is inverted network mask. And the second one, this time, the source is 20, the destination is 10. So it's just the other direction. Internally, the system introduced 2 rules for both directions. It implies the system has the ability for 2 different directions have different rules, but on the UI, it doesn't give us that flexibility. From rule 1 to rule 8, they correspond to the 4 entries we created, right? Then let's see what's the last rule. Very simple. The action is permit. If we don't isolate the networks, the default action is permit. In fact, that's why, see the diagram, these 2 green lines, we didn't do anything about them. We already validated the accesses are allowed, right? Why? It's because of this last rule. Default action is permit. That makes sense. On the UI, we see 3 entries. In the backend, there are 4 rules. And then internally, we see 9 entries in the ACL. So the ACL setting is pretty straightforward from both front end and the backend. Before we move on to 2 layer 3 switches scenario, let's discuss one more details. From the front end, Ubiquiti differentiate the source network and isolated from. It may give you the illusion that these two things are different. There are some type of directions, right? In fact, it's not the case at all. Let me do a very simple testing. Let me remove all the existing rules first. For the first testing scenario, let me create a rule from VLAN 20 to VLAN 10 and VLAN 66. Create. Apply changes. In the SSH, let's check what's the generated ACL. This time is very simple, right? Just 5 rules. And for the 2 entries we created from VLAN 20 to VLAN 10 66, it generated 4 actions. So then let me remove this rule. This time let me create 2 rules. Instead of from 20 to 10 to 66, let me create one from 10 to 20, then from 66 to 20. Just from the UI, I simply switched the 2 columns, right? Apply changes. Now let's check what's the backend generated rules. You can see the generated rules are exactly the same. So which means there are no differences at all. I believe the reason Ubiquiti designed the user interface in this way is in the future, it will enhance it to support directions, even though now the differentiation doesn't make sense at all. Okay, so now let's move on to the scenario. What if we have 2 layer 3 switches? In my lab environment, I have 2 layer 3 switches. The other one is a non-rack mount 8-part enterprise PoE switch. For the first small switch, I have 2 VLANs, and for the original 24-part switch, I have 66 and 88. If I want to achieve this type of access, it's very possible your immediate thought is, okay, it's between 2 switches. Let's use firewall rules, right? If you really go to UniFi firewall settings, you are rarely able to define such firewall rules. So from VLAN 222 and the destination VLAN 66, the action is dropped. It seems the system allow you to do this, but let's do a simple testing. So from the lower side, from VLAN 222 Linux, let me ping the VLAN 66 machine, right? Even though now the firewall rule is already active, I'm still able to ping it. So the root cause is exactly the same as what I shown you earlier when we only have 1 layer 3 switch. In fact, it doesn't matter whether you have 1 layer 3 switch or 2, as long as your VLAN is managed by your switch instead of your router. You have the same situation. The traffic will not go to the router, so your firewall rule doesn't make any effect at all. To achieve this type of access, we still need to rely on ACL. So let me go to ACL, create such access list. Let me first delete this useless firewall rule. Then go to network. I already disabled the layer 3 network isolation. Now let me enable it, create entries, and from 222, the destination is 66 and 88. Okay, just 1 entry with 2 rules. Apply changes. In the lower part, in this Linux terminal, I show you 2 windows. So one is SSH session to the first layer 3 switch. Second one is to the other layer 3 switch. The first switch is not rack mount. It has special CRI, so The format is slightly different, but the content is the same. In the first layer 3 switch, let me show access lists. You can see it lists 4 deny rules. It's between 222 and 6688, right? And in the right side, let me run the same command, show the access list global IP ACL. Same thing, right? 4 rules and then followed by a permit rule. In the left side, it doesn't list the permit rule. It's just due to different command line output. Internally, it's the same thing. It still has a default permit rule. It doesn't matter it's in which switch, the ACL setting is the same, but we only did it once on the UI, and the system automatically creates the ACL in all the related switches. Because the ACL is active in the right side, VLAN 222, let me ping 66. Yep, this time it works. For the scenarios of 2 switches, the setting and the testing is very simple. We are good. Now let's go back to the topic we put aside earlier about firewall rule or ACL. In fact, you can think of ACL as a special type of firewall rule. It's stateless firewall rule. For example, in the UniFi network controller, if you create a firewall rule, you can see a lot of settings. And especially in the advanced part, you have more controls. You have control about the state of your packet. But when you define ACL, as shown in the SSH session, the control is very simple. You just deny or permit, you indicate the subnet, that's it. For our case, for the network isolation purpose, if the traffic will go to the router, for example, in this case, between VLAN 10 and VLAN 20, or between VLAN 20 and VLAN 66, the network traffic will first be routed to the router. The firewall rule will be effective, so if you want, you can choose to define the firewall rules instead of ACL. But if the traffic is only within the switch, for example, between 66 and 88, you have only one option, which is ACL. As the last part of the video, let's discuss the limitations or something I hope Ubiquiti can improve in future releases. First, let's talk about default network. So let's say you have VLAN 66 and 88 managed by your layer 3 switch. If you want to control the access between these two and the default network, you may find it's not possible by using ACL. Let me show you. So let's create an entry. So for source network, you can see default network or VLAN 1 is not available here. Let's choose 66. You can see for the destination or isolate from network, default is grayed out. And the reason, as explained in the tooltip, because the UniFi network application is running in VLAN default. So you cannot create ACL. Then you may ask, why in firewall rules you are able to define the firewall rules for network default? That's because in firewall rules, you have more granular control. It's much more flexible, so you can achieve what you want without impacting the network application's regular functionality. But ACL is too simple, too brutal. It simply cut all the access. That's why default network is not allowed. So if you want, you can use firewall rule. By the way, we are using default network as example here because normally your network controller runs in VLAN default. But if you run it in other VLAN, then the same limitation apply to that VLAN. Next, about direction. Even though now on the UI, Ubiquiti differentiate the source network and isolate from network, but in fact internally, they are the same thing. They are equal. So Ubiquiti simply deny the accesses between two of them. But what if, for example, you want to allow 66 to access 88, but not the other way. Based on the current user interface, you are not able to achieve that, even though internally the command line does support it. I believe it should be an easy enhancement for future Ubiquiti UniFi network controller releases. This is about the direction. The next part, you want to go even more granular way. For example, within the same VLAN 66, you have two computers and you want to control, okay, from the other VLAN, you wanted to access one of your computer, but not the other. So for this type of granularity, of course, currently on the user interface, it's not supported, but again, internally in command line, it is possible. So you can define the MAC address or IP address level access control. It is supported in backend. I don't know whether Ubiquiti will enhance the user interface to this type of granularity in the future, but let's hope so. Okay, this is the end of this video. Thanks for watching.